right, so we are live and hey everyone, welcome to another session of TestMu 2024. I'm Harshit Paul, Director of Product Marketing here at Lambda Test, and I'll be your host for this session on using personalized AI agents to speed up software development and improve code quality. Today we have with us Eran Yahav, a leading expert with extensive experience in AI-driven software development and code quality. Eran is renowned for his work in integrating AI into the software development lifecycle. And today, Eran will help us understand the role of AI agents in modern software development, how personalized AI can accelerate development cycles to improve code quality, some real world examples and case studies on successful AI implementations, and more. But before we get started, let's quickly take care of a few housekeeping items. This webinar is going to be a 45-minute long session. So in case you need to drop off midway, the entire session is going to be recorded, and you can find the full recording of this session over the AirMeet TestMu platform where you are accessing the webinars from right now. And you will also find the full recording of these sessions over to Lambda Test YouTube channel. You will also have the full recording circulated to you over your registered email address. Having said that, we will be taking Q&A as they come and go. So if whenever we are presenting and you have some questions in mind, feel free to put them in the chat box and we'll take them as we go. Having said that, Eran, thank you so much for joining us today.
Sure,
And the
my
stage is
pleasure.
entirely yours. Please take it away.
All right, thank you. Thank you for having me. I'm gonna start off by maybe asking people here, uh, take a poll on who are we talking with right now. Feel free to vote, and I'm happy to take questions throughout the presentation. We don't have to wait for the end. Feel free to drop questions at any time in the chat, and I'll take them as I go. That will make things more interactive and more fun for all of us. So I'll give you like a few seconds to complete the poll, just so we see what's going on here. All right, a few more seconds, and then I'll share my screen.
Yeah, I see
If
the
there are
tallies are
any,
still going up in the voting
yeah,
tallies going up.
yeah,
Folks are engaging there.
exactly. Yeah, so I'll give you couple more seconds to do that. And if there are special requests in the chat, you can paste them while the other people are voting here. And all right, so this looks like we have enough votes to see like the breakdown of the audience. So a lot of test engineer, developers, lead of quality. And all right, I'm gonna close the poll at this point. Oh, you keep on voting. So I'll just hide it and not close it. You can keep on voting. I'll revisit that later. I'm gonna share my screen here for the slides. And again, happy to take questions at any point. I'm gonna talk about really personalized AI agents, the importance of testing in this universe, and how are we going to speed up software development and software quality in this new universe. So it's pretty clear if you've been looking around that we're moving into a world in which some software development is going to look like this. Here I have on the right-hand side a Jira ticket, which says create a trading app and having this trading app some field for the ticker symbol, buy and sell buttons, and stuff like that. And I'm just going to my IDE, pointing to this Jira ticket. And what's going to happen now is, in this case, Tabnine implements this Jira ticket and gives me a fully working React application that I can just use to buy and sell stocks. No recommendation intended in this demonstration. Right, so we are moving to this world in which at least some of the tasks that we have to do as developers, as engineers, are going to be handled or assisted by AI. And really, if you want to look at it like one step back, AI software development is really beginning to be realized on a massive scale. And we can look at this on two dimensions. One dimension is like what is the ability of the AI to act autonomously, and the other is what is the percentage of software engineering tasks that are being currently addressed by AI. And in the happy universe, we are maybe here, where all tasks are handled autonomously, completely by AI. But this is not the reality yet. The reality is that we are somewhere on the path from coding assistants to the AI engineer, and some tasks have already kind of made more progress than others, and we're somewhere on these boundaries here, like making our way towards the engineer for certain tasks. Yeah, hi to everyone who's joining now. Again, happy to take questions at any point. So we're already seeing these tools, AI assistants and some AI agents delivering measured productivity gains across software development tasks, and these can go anywhere from 20 to 50% productivity gains. So right now, if you look at the AI software development landscape, what we're seeing is that AI supporting us throughout the SDLC journey. We have basically a process that is managed by a human engineer. So that takes anywhere from an idea to a production deployment throughout the entire SDLC, but the human is really the one driving the process. And we have these assistants, the AI agents, that are helping us in the different verticals of the SDLC, or different steps of the SDLC. So we may have an assistant that helps us code, we may have an assistant that helps us do some testing, another assistant that does code review, and maybe one that does deployment assistance, right? So we have, like, for every kind of step in the SDLC, we have the human engineer collaborating with the AI engineer to accomplish the task, but the AI is just an assistant, and the human is the one who is really driving the process here. But if you look one step into the future, and this is really consistent with the Jira demo that I showed you initially, we are looking at a process that really has 3 steps only. It has an ideation phase in which the human and the agent are collaborating to create some design and requirement elaboration. Then a generation phase in which the human engineer is really doing more requirement elaboration, like breaking down the tasks even to like more refined things, and then handing off the code creation, code generation completely to an autonomous AI agent that's going to do that. So we have ideation, we have generation, and then we have a super important phase for this audience, which is validation, right? We have these AI agents that are basically, together with the human, are going to generate massive amounts of code, right? They're going to generate code, generate more and more code here. Code is getting generated faster and better, but at the end, we would also need to scale up this phase of validation, of testing, of all the tools that we have to enforce software quality to scale as much as the AI code generation scales, right? So the bottleneck for this entire process, if you want to really get high quality results, is becoming the validation phase rather than the generation phase. Again, any questions? Happy to answer at any point. Good afternoon, Paul. All right. So when we think about AI in the SDLC, I'd like to think about it really as a delegation problem. And if you look at it, you can think about it from what I call the fundamental theorem of generative AI, which means that it only makes sense to delegate a task to an AI agent if the cost of telling the agent what to do plus the cost of checking back the result from the agent is much, much smaller than the cost of doing the work yourself, right? So if it takes me a lot of time to tell the agent what I want and how I want it, and then is this really what I wanted when I get back the result? And also, can I trust this result in terms of security, compliance, and performance? Maybe I'd rather do this work manually myself, write the code myself, right? So I really need somehow to get this, both the question of how do I tell the agent what I want and the ability to trust the result that I got what I wanted to be solved and streamlined for GenAI to be useful for me in the SDLC. So when I work with an assistant, I really get trust by having a tight loop integration with the human, right? So what happens when I'm doing work or code generation with an assistant. I basically have the human engineer have some specification. This is often implicit. You get code completion as you type, or you type a small comment and get a prediction, or maybe you write some small short instructions in chat and get some code generated for you. And so basically this kind of specification is very, very lightweight. The human doesn't have almost to do any work in order to provide this specification. Agent goes off, does whatever it does, and comes back with some code, which can be, 50, 100, 200 lines of code, not more than that. And this goes back to the human, and now the human engineer, she looks at the code that came back from the agent, says, yes, I apply my common sense judgment, and I either accept it, or I take it into the source code, or I'm going to basically reject that. And so we are getting trust in the code that is being generated by GenAI by having very tight human-in-the-loop integration. So just as concrete examples, let's say I wrote this function signature get tweets, and I get two possible completions. The one on the left is a code completion that uses some library called tweetpy, and the other one here is basically just doing the HTTP request directly using the request library. And so as a human, I can apply a judgment here and say, oh, you know what? I prefer the library. It's probably tested, and I look maybe at the metadata of the library and see the quality. I see that the library is a trusted one, etc. So I may pick this one. Or if I see that the library is not that great, I may pick this one. But I'm applying human judgment in order to take the right completion into my code base, right? So the developer here can be trusted because the developer is a human. Moving to the next step, if I have some piece of code and I say, hey, I tell the AI, make this code better. That's my spec. And the AI refactors this code and gives me this original code right here. I get from the AI the refactored code, so you can see what this code does. It converts two variables from Fahrenheit to Celsius. And the refactored code here is just doing the same, but has kind of a common function for doing the conversion itself. So it's slightly better code, but again, in this case, it's maybe obvious that it's better. In other cases, it could be a matter of taste or a matter of human judgment. And again, we are trusting the human to make the right judgment and kind of get the right result here. Right, I don't know if there was a question that I missed here. Is there anything coming? All right, I see things that are coming in the Q&A and not in the chat. All right, that's also good. I'll pick those in a second. Yeah, okay, I'll stop for questions in a second. So how can we basically create trust in the AI engineer? I'll answer the question about the potential risks and the specific tasks in the software lifecycle in a second. Just in terms of how we create the trust in the AI engineer, I think there are really three main vectors to establish this trust. One is personalization. We need the AI engineer to really understand the company's code base and corporate standards, right? When we give an AI engineer the task of writing code for our organization, if the AI engineer has not been onboarded to the organization, it is going to generate code that is not compatible with our best practices. It's going to generate code that is not suitable to how we do things around here, right? It may use libraries that are not libraries that we use. It may circumvent certain logging and authentication mechanisms that we use. It may regenerate code rather than use existing libraries or microservices, right? So we really need, as the first order of business, if we want to ensure high quality from our AI engineers, we need to onboard them or to the organization, or as we call it, personalize the AI to the organization. The second thing that we have to do is we need to provide the architects, the development managers, whoever, the quality leads, the test engineers, whoever is in charge of quality in the organization, absolute control on what the AI is generating, right? We need to give the people who are in charge of quality the ability to control the scope of the AI, the behaviors of the AI, and the decisions that it makes. The third thing that we need to do is kind of make sure that we increase autonomy to the level that the delegation boundaries are such that it is easy to describe to the AI what is it that we want it to do and easy to consume back the results. So we are really making this progress from the assistant to more autonomous agents to really a full-blown AI engineer. And if we're doing all these kind of three things correctly, the AI engineer will really be the employee of the month of the company on every month, right? With the best engineer that you have. It will know all the code base, it will know everything about the company. You will be able to control exactly the quality of the code that it generates, and it will be very easy to work with the AI engineer because you will basically communicate with it with the right level of autonomy. So I'll stop here to kind of take a few questions. One question that I see here, I'll refresh the votes. One question that I see is like, what specific tasks in the software testing lifecycle can be most effectively handled by personalized AI agents to reduce time and improve accuracy? So if we go back to the SDLC in general, right, let me clear my annotations here. I think some tasks here are clearly more automatable than others, right? So for example, unit testing, unit test generation is something that can be automated quite nicely by AI, and the code that it generates is test code that does not go to production. So the risk of the AI injecting really bad code, into your production code base is lower. So testing, and in particular unit testing, is a good fit right now for AI agents in general and Tabnine in particular. Another place that we are seeing a lot of value is in automated code reviews, where you can use AI agents to automate. Again, don't think about it as automating the most complicated tasks that you have, in your code review, but it can automate a lot of the mundane review parts, and I'll show maybe some examples later. And the AI agents have advanced to the point that they can do more sophisticated and different things than the ones that you would find with linters or with standard static analysis tools. They just look at the problem slightly differently from a technical perspective, that what you're going to get is different review comments that are complementary to what you would get from a linter or from static code analysis, but also with lower false positive rates. So it will be a deeper code review that will maybe give you surprising things that you would not be able to find with other techniques. So these are two places. If you're asking specifically about validation, I think both of these, like unit testing and automated code review, are really kind of sweet spots of the technology today. Obviously, a lot of the AI in software development right now is focused on code generation, documentation generation, test generation, and the more generative, let's call it the generating part of the stack. So I hope that answered your question, but if not, feel free to elaborate on that as well. As to potential risks of relying on AI agents for code generation, yeah, there's definitely some risk. I think the risk is mostly because we are relying, as I said, our entire trust in this process right now is based on the human judgment, who is basically interacting with the AI agent at the granularity of, let's say, 100 lines of code. So the human is specifying something either in chat or as code completion, gets back results, and then we are trusting the human to apply judgment and either take the code or reject it, right? If humans are kind of willy-nilly accepting things into the code base without applying steady judgment, then that is definitely a risk. A risk to quality, which is not that obvious, but I think we should pay attention to, is that of duplication, because AI code generation agents are basically generating code. They are maybe regenerating certain pieces of code similar to what you already have in your code base, right? So maybe had a human done that, they would realize that they should refactor this and have a common library, or maybe they would just like look for the appropriate microservice. An AI agent that has not been onboarded properly, or an AI agent that is just keen on generating, may just basically generate technical debt by creating duplications and many variations of very, very similar code. And so part of what we're doing in Tabnine is trying to make sure that this doesn't happen. But this is definitely a risk to the code quality that people should be aware of when adopting these kind of agents. Does that answer your question, Hesh? All right. I'm going to proceed a bit, and then I'll go back to questions. If your question is not getting the attention that you want it to get, feel free to comment on the question, and I'll see that as well. I see that Amaya is also picking up questions, so thank you, Amaya, for doing that. So I have some ground crew here. Appreciate it. All right, I'm going to keep on going. All right, and so one of the main questions that is also coming up, in your Q&A here is, okay, how do I get an AI engineer that I can trust? I understand that when I'm doing like very tight human in the loop iterations, I rely on the human, but what happens when I'm doing like this more high level agentic AI engineer kind of workflows in which I provide a high level spec, and now the agent comes back and gives me thousands or tens of thousands of lines of code back. Clearly, the human is not going to be able to play defense against these amounts of code, right? So we need a better approach for making sure that we can trust the AI engineer. And so, as I mentioned earlier, it's really about both personalizing, making sure that the AI engineer is aware of what already exists and is aware of the organization, and also getting this notion that I'll talk about in a second of coaching, of being able to control what is it that the AI is generating. So really the way we look at it is really, it's an architecture diagram, but I'll just explain the principles here, which is really the separation that I mentioned earlier between ideation, generation, and validation. So we have basically two kinds of agents. We have agents that are generating stuff, let's say agents that are generating code or unit tests, and we have validation agents that are then testing and checking and validating the work that has been done by the generation agents. And so the role of the validation agents is critical for the success of this system, right? Because as I said, as more code is being generated by agents, we also need to automate more of the validation to scale together as generation scales up, right? Because we cannot have agents just generating stuff and humans playing defense to review that and to validate that. We need to also scale the validation stack such that whatever gets generated gets reviewed properly, and we get it to adhere to security, compliance, performance, quality, right? All the things that we are responsible for. And so the way that it is done in our world is by using what we call the context engine, which combines information from many, many data sources to get good visibility of the organization, understand the different aspects of the organization by connecting to organizational systems, and then basically feeding into these agents, providing the necessary data to these agents. Because maybe again, I'll take a step back. I know these are a lot of details on the slides, but just take a step back. Conceptually, for the AI engineer to be successful, it needs to have the same visibility as a human engineer does, right? If we are hoping that the AI engineer is going to be able to fix the bug, for example, the AI engineer will benefit greatly from looking at historical support tickets that relate to similar bugs, look at stack traces and crashes from application monitoring, look at the entire code base, look at whatever, all sources, confluence for best practices, look at all these sorts of information and integrate them into kind of a holistic picture of what's going on in the org. That's the personalization part. And then there's the control layer here, the control part. And what control part lets you do, it lets you tell Tabnine what you would like to do, what are the best practices, what are the standards, policies, the permissions, what is it that you would like the validation agents to really check. And the idea here is that by using the control layer, you can really tell the AI what is it that you would like it to do? What are the rules of the game, right? You need to put some structure around all these things that are being generated. You need to put some boundaries, some guardrails to make sure that you don't lose track of quality. And this is where the control layer comes in, and I'll show you examples in a few seconds. Right, one agent that I think is really important for the discussion here is a test generation agent. And as I mentioned, the agents are personalized and also getting an increased level of autonomy all the time. So in this case, what the test agent does is generate unit tests, but in order to do that, it first generates a test plan of what is it going to test for you, and only then goes to generate the individual tests, the individual unit tests. So it's kind of an agent that first does the planning of the testing, what we should be testing, and then actually implements those unit tests. And obviously, because it's personalized, it knows about the existing tests in your system, and you can obviously add things to the test plan, remove, modify things in the test plan, etc., before you go ahead and kind of ask the agent to implement the test plan that you just designed. Let me stop here for a few more questions, see if we have things that are not answered. So this is an interesting question here. Can AI agents assist in automating complex task scenarios or edge cases that are difficult to cover with traditional testing methods? So that's a great question. I think what we found is that they're really good in generating data, right, inputs that are maybe surprising or interesting. It's not yet appropriate to use these agents, if you have 90% coverage and trying to get the last mile there. That's probably not going to close that gap, but it's really the technology that can take you really quickly from 20% coverage to 80% coverage, because it can cover a lot of interesting cases without you having to think too much about them. For example, just maybe a silly thing, but in this example, as I was building it, what we're seeing on the slide here, the original unit under test was a method that sets the date of birth. It's just a very, very simple thing. And I did not test in my tests for having date of birth that is in the future. And in the previous iteration of running the test agent, it kind of added this test for me for date of birth that happens in the future. So I think, again, this is a really, really simple example here, but it can generate data that is kind of more rich than maybe what you would imagine as a human, and it can really bootstrap you or get you to a good degree of coverage without a lot of effort. I think that's really where it shines, rather than closing the last mile, where the super complicated use case that you really need human reasoning in order to capture. Is there any consideration for running small batch full life cycle for any given request using a many agent approach? All right, I'll wait with that. Can we use agents to automatically write integration test cases or providing source code of application? Yes, we've seen some work on kind of scenarios or behavioral testing, and we've done some work around that. I don't know what is the sophistication of integration test cases that you imagine, Mohammed, but that's something there should be doable. Again, think about the AI agents as things that are taking away the simple stuff from you, so you don't have to worry about it. The mundane stuff. So if it's a simple integration test with a very clear scenario, absolutely, this is a good match. Don't think about it as technology that will solve the most complicated thing for which you need super clever human reasoning. That's like a lose-lose, right? It will be hard for the AI and maybe much easier for the human. All right. Excellent question from Christoph. How can AI testing agents such as Tabnine validate the correctness of their generated tests? So this is always a challenge here, right? Because we start with something that is not really a clear specification, right? So you start, should handle, well, this example is too simple to kind of show what I mean. But because we are generating tests from source code that has already been written, what the agent does is basically speculating what the actual specification should be. We are not starting from a higher level specification, right, Christoph? And so there's kind of a gap there. I think moving forward, as we start to contextualize on things like the Jira ticket that I showed in the first slide of my talk, we'll be able to pick up high-level specs or description of the test case or the test scenario, and make sure that the tests are really matching what is defined in the test scenario. Does that answer your question? I mean, obviously, you know, we run the test, etc. Right? This is obvious, but I think there's maybe you are talking about the gap between the spec as we extrapolate from the code versus the actual spec as appears elsewhere, and we do not contextualize on yet, right? So, but think about the ideal scenario in which we do have a Jira ticket or something in which there's the specification of what this method should do, and we start from there. All right, I'm gonna continue here, and then we'll maybe look at a few more questions. All right, so basically what I'd like to spend the rest of the talk on, I'd like to maybe talk about my wish list for an effective AI engineer. This is, you can think of that as like the job description when I'm going to hire my AI agent. And what I would like my AI agent to be, I'd like it to be obviously personalized, as I mentioned earlier. If I don't onboard it to the organization, it's not going to be very effective. I want it to be concise. I want to be able to communicate with it effectively. So I don't want to explain things in a very extensive way, and I don't want to get very extensive results. I want to be effective in the communication, just like I'd like to be effective in the communication with the human engineer. I'd like the AI engineer to be inquisitive. So when I ask it to do something and it does not understand or need additional details, I need it to come back to me and say, hey, Ron, I'm not sure about this. You asked me to implement a calculator. Did you mean that I implement a scientific calculator or a standard calculator? I need this additional level of information. And I want it to be reliable, which I think is really important for this audience. So I'm gonna rush a bit and get to that point of the conversation. So just to kind of explain this, elaborate on personalization. Personalized means that really the AI agent knows and uses existing work rather than reinventing. And it needs to know both the problem domain in which it's working and also the solution domain. It needs to also adhere to some guidelines that I have in my organization, right? Don't access the database directly, access it through some wrapper that does authentication, validation, logging, etc. Right? So all these things I want the AI engineer to know as it gets into the organization. And the way that we do that is we basically combine several techniques to get there. So we combine what we call context, which means that the AI agent is aware of anything that exists on your local machine. It contextualizes on everything on the local machine and can leverage that. The next level of personalization is what we call connection. And connection allows you to connect Tabnine to all sources of information in the organization. So you can connect to organizational repositories, Jira tickets, etc. And this again gives the AI engineer more visibility, more context, as this is going to perform its tasks. And next level is coaching. using coaching, you can provide Tabnine with explicit guidelines and instructions on what you would like the code that's being generated to comply to conform to. So this is the way for the architect, for the quality lead, for test engineers to say exactly what they want the code to adhere to. So this is a way basically to enforce quality across the system. So enforce guidelines and compliance across the system, which is, I think, really important. And the last one here on the customization journey, is customization, which gives you the option to really fine-tune and customize models using your entire code base as training data, etc. I will not have time to talk about that today at all, but you can hit me up later and we can talk about that offline. All right, importantly, as we work with AI agents, it's important to understand that context is really everything, right? Providing the model, providing the agent with appropriate context dramatically improves the results. I'm going to rush through this a bit so I can answer a few more questions. And when you look at context, basically, you can think about context as going all the way from, hey, the AI agent is just, having no context at all, or you can say it contextualizes on everything in the organization, including non-code sources of information, Jira, Confluence, Zendesk, you name it, right? So there's kind of a range here on how much the AI agent is aware of. I know it can be aware, for example, of the entire code base or just the currently open file in the IDE, right? And really, if you look at AI agents or AI assistants and you ask something like, okay, please display a table with student scores. I have some Python project here, and I'm asking a very simple question, a seemingly very simple question. Well, what you will see is that the AI agent will typically look at a ton of things in order to make intelligent decisions, something like the current file, the other open files, the current selection, errors, runtime errors, other project files, project metadata, Git history, conversation history, imported libraries, connected repositories, and non-code source information. So it really looks at a bunch of things in order to give you a personalized experience and generate the things the way you want them, rather than start, regenerating everything from scratch, which again, as I mentioned earlier, creates a lot of duplication in the code base and also technical debt. All right, so when you look at this technology and look at the underlying language models work in a way that has a limited context window. So context window is measured in tokens, and language models typically have between 8K tokens to 200K tokens. And recently there are aspirational claims around 1 million tokens in the context window. But it's important to understand that as we put more things in the context window, the latency increases and the accuracy of the performance of the LLM typically decreases. And so really the context sources are competing for attention, and kind of like when, as I said, you get like this simple question of display table student scores, so you get many pieces of relevant information from the context that I just mentioned earlier, and you somehow need to understand how to place them in the context, how the agent really conveys all this rich information to the agent in a way, to the LLM and to the agent in a way that gives you the right result. So this is typically done, when you want to implement this level of context awareness. This is typically done by implementing retrieval augmented generation. And in retrieval augmented generation, the user writes a prompt, you hit the retrieval algorithm. The retrieval algorithm then goes to consult both the local project and maybe some remote repositories and other non-code sources of information. And that creates an augmented prompt that hits either a custom model or a universal model in order to produce the result. So there's a lot of smarts in the retrieval algorithm, but I think being mindful of time, I'll skip ahead a bit and I will not talk much about the details, although you will get the slides later. and you will see all the details there. Let me skip ahead a bit, just so we can cover also something about coaching and reliability, which I think is important for this audience. So really, coaching or reliability, as I mentioned earlier, is the control layer in the nice architecture diagram that I showed you. It's the way in which you can tell the AI agent what is it that you want done. In this case, what you see here on the right-hand side are comments from the automatic reviewer. And you see, for example, it says, do not send requests to the target server without implementing rate limiting, right? So this is kind of a report that is found by Tabnine automatically during code review in the pull request, which may be completely novel and is based on rules that are built into Tabnine. So you can have thousands of rules. You can use thousands of rules that are already built into Tabnine, and you can add your own rules as well using natural language. So if you'd like to use this module, what you provide is basically coding rules in natural language, like do's and don'ts. Don't connect to the database without working with the Eran connector, or I'll show a few examples in a second. You can provide the golden repository of code to prioritize, as well as snippets and examples of expert solutions. And what you'll get is you will get flagging of these deviations in the pull request, merge request, ID, and command line integration. And you will get the generation of code to be biased towards these best practices. So there are thousands of built-in rules in the agent, and you can obviously add your own as well. And as I said, it integrates into all your source control, your favorite source control. In the way of examples, I think really important things like use the standard. We see that a lot. Use the standard or internal organization libraries, enforcing that by creating a very simple custom rule in natural language, forcing people to do things the right or idiomatic way. Importantly, reusing instead of reinventing or replicating, and preventing new legacy. As you're trying to shift to a new API or a new library, you don't want people to keep on writing stuff with the old library. So you want to be able to prevent this new legacy from being created, and that's something that's very easily done. I think we have like a couple of minutes for question. How do you find a good balance? Oh, wait, I'll see if there's another question that is voted higher. Yeah, so I'll take the last one. Can you explain a bit about the onboarding process for the AI agent? Yeah, I can explain that the onboarding process for the AI agent consists of basically connecting the AI agent to the relevant code bases or maybe other systems like Jira in organization. This typically requires some work because you don't want to connect it to all the code base. The entire code base of the organization typically contains things that you don't want the AI agent to know. There's typically legacy code that you'd like that it doesn't actually know. And so it requires some work from the customer side to understand what is it that you would like really to tell the agent as you onboard it. So you need like an onboarding plan, so to speak, of what code and what other systems and projects you want the agent to connect to. One last question, how do you find good balance between reliability, accuracy, and speed of the test? So right now, we do not try to optimize that at all. We're just trying to generate tests that improve coverage. So we're not taking, the latency of the tests into account right now. That's a good comment. Again, I don't know how exactly to factor that in, but that is a really good comment. I think in the interest of time, I will have to stop at this point. And thank you all for joining me today. I appreciate your time. Feel free to contact me offline if you have any questions, and I'll share the slides so you can see the stuff that I did not get a chance to present. Thank you.
Yes, thank you so much for the session and your informative, detailed answers to every question that got popped up while we were having this presentation, Aaron. And thanks everyone for joining in as well. If you have any further questions, feel free to drop them over community.lambdatest.com. That's the Lambda Test community, where we can address further questions that you might want to put towards Eran and Lambda Test. And thank you for joining in. Have a great day. Bye bye.